less these slopes, which we are referring to inclined, what I need you to know about the slopes is that, okay, so on the slope, the perpendicular the perpendicular resultant will be equal to 0 newtons. That's what you need to know. Then the parallel one, this one, we say that the resultant determines acceleration. Okay?
Okay.
Now that you are happy with that, now I need you to always remember, this is very important, very, very, very important. So now look at this. The FG parallel, you still remember the FG parallel is equals to FG, the cos of theta.
Cos of theta, yes.
Oh, I'm sorry, the sine of theta, not the cos. Remember, the cos is the one for the perpendicular.
Okay, Manu.
So each and every time you have FG parallel, you can substitute it with FG, the sine of theta, and the FG perpendicular is equals to FG, the cos of theta. Right. So now, let's say that we have the force applied down the slope. Let's start with that. Let's say we have the inclined like this.
Okay.
You're still sleeping?
Yeah. Ish. Many.
What time did you sleep yesterday?
I think I slept at 12 because I was busy with momentum.
Oh, okay. Okay, I'm trying to make a drawing here. So now the force is applied down the slope, meaning that the box will move down. The FG parallel will go down. This will be the FG parallel. Okay. So now what I need you to note on this is that the FG perpendicular is always perpendicular to the surface. The normal force is also perpendicular to the surface. So now, if this is the case, remember we have this angle here as theta. And now, for the fact that this is moving down, this tells us that the frictional force will go up. Are you happy with those forces? Okay.
Yes, sir.
So now, when it is like this, you're going to focus on this side. We're going to talk about the parallel forces. And this side, we're going to talk about the perpendicular. You understand?
Okay. Okay. Sir.
Right. So when we say the parallel forces, we're going to take all the forces that are parallel. Maybe it's best if we do the free body diagram indicating all the parallel forces. For example, we have the frictional force going up, FF. Then what else do we have? We have the force applied.
FG.
And what else do we have? We have the FG parallel. Okay. So what you're going to do, remember the parallel, this is Newton's law, is going to be F net. F net is equals to MA. Okay. So F net, we choose direction. Where is this going? It's going down. So we're going to take down as positive. Okay. So all the forces that are going down will be positive. So we'll take the FG parallel, you add it with the FA, you subtract all the forces that are going up, okay? Equate this to MA. So this is the formula that you're going to use when the force is when the force is applied down the slope. I think we need to also note it down here that the force is applied down the slope. You're going to see why this is important. Trust me, whatever that we are currently doing, if you understand it, it's going to be easy for you to work on examples, okay? So,
okay, sir.
if the force is applied down the slope, so this for parallel, that is the formula you're going to use. So now let's talk about the perpendicular, because I'll need you to draw the perpendicular free body diagram for perpendicular forces. This is FG perpendicular. So now we have the normal force going up, which is Fn, and what else do we have? We have the FG perpendicular going down, okay? So this is the FG perpendicular. Then let's say that F net is equal to 0. Remember, for horizontal we said for the perpendicular, the normal force is 0. Okay? So now what you're going to do is that you're going to say F net equate this to 0, and we take up as positive. So we're going to take the normal force, we subtract the FG perpendicular, and equate this to 0. So this is the formula that we're going to use if for perpendicular forces, and this will be the formula that we're going to use for horizontal forces. So I think it's best if we do highlight these forces. Let's highlight them like this, because when we do examples, we're going to come back to these formulas, okay?
Okay, sir.
Are you happy with that?
Yeah, boo. 100%.
Yeah, and this is what you need to understand before you can even go to questions. This is where you start, okay? Okay. Now, let's say that the force this time, let's talk about the force. Let's say that the force this time, it's applied up the slope. So now let's say that the force is applied up the slope. So if the force is applied up the slope, so we're going to draw that our inclined theta, put our object like this. So now we know that the F applied is going up. This is F applied. Then we have the normal force. Then we have the FG. I know that what we are doing sometimes it might be boring, but trust me, this is going to make sense when we currently work on examples. So then we have the FG parallel. We have the FK. So now I need you to pay attention. The FG parallel, you see this guy, the FG parallel, it always goes down. Always go down. If the force is moving up, it's going down. If the force is going down, it's going down. You understand?
Okay.
So from this, we're going to have the parallel. Let's try with the free body diagram. The free body diagram, we're going to say we have the applied force going up. This is my applied force. Then we're going to have my FG parallel. Then we're going to have the frictional force. Then we have the FG perpendicular going down. And what else do we have? We have the normal force. So now we need to know the parallel and the perpendicular.
Okay.
Right. So on the parallel, first thing first, let's choose the direction of the motion as we're going to say F net. It's equal to MA, and I'm going to choose the direction of the motion as positive. So we're going to say if up is positive, we take the applied force, we subtract all the forces that are going down, we subtract all the forces that are going down and equate this to what? To MA. So what is the difference between these two? This side we were adding Fg and Fa, then we subtract the frictional force. But when the force is applied up the slope, we're going to say Fa, we subtract Fg and Fk, okay? Right.
Okay.
Then for the perpendicular, remember, we're going to say F net, it's equal to 0, and we take up as positive. So the perpendicular will remain whatever that we got on the other side. So we're going to take the Fn. Okay, let's do this. That we take up as positive. Then this simply means that we're going to have the normal force
minus FG perpendicular.
FG perpendicular. Then this is equal to 0. And that's it. That's
Okay.
it. Are you happy with that?
Yeah.
Okay. So now, when you understand this one, I think on the next one, that's when we're going to start working on some of the examples so that you can understand what is going on before we can talk about lifting object, connected objects, okay?
Okay,
Nice.
so